Hi, my name is Professor Deb Stockbridge. This PowerPoint presentation is based on the 6th edition of Absolute C++ by Walter Savage. It was published in 2016 by Pearson Incorporated. This presentation is for the C++ programming class at Quincy College, but everybody is welcome to watch it. In Chapter 7, we will learn about constructors, how to define them, how to call them. Additional topics will include inline functions, static member data, and vectors. Constructors are automatically called when an object is declared. They are functions that give values or initialize the private data members of a class. Constructors make sure that only appropriate data is assigned to the private data members. They are also declared in the public section of the class. So defining a constructor is very different from defining a function. Constructors do not return a value. You don't even put void in front of them. And they must have the same name as the class. This slide shows the new definition of the time class. You'll notice that we have two functions that are public, that they are the constructors. Time without any arguments is the default constructor, and time given two integers is another constructor. The constructor on the top is a default constructor because it does not have any parameters. This constructor sets the hours and minutes to specific values. The constructor on the bottom allows the user to set the values for hours and minutes. And then on the right, you see the definition of both constructors. You put the name of the class and then the scope resolution operator, which are those two colons. Then the name of the constructor, which is the same name as the class. So as a default constructor, when they create an object, hours is set to 12 and minutes is set to 59. The definition for the constructor on the bottom lets the user decide what hours should be and what minutes should be by passing those values when it's called in the program. This slide shows the code for calling the constructor in the main function. When an object is created, the constructor is automatically called. In the first example, an object named another day is created and the arguments are given. So hours would be 7 and minutes would be 12. The next object, which is created, is named February 29. There are no arguments given, so the compiler will use the default constructor, which sets hours to 12 and minutes to 59. In the textbook, there's a full program that shows a class with a constructor. It's on pages 286 and 287, and I will be going over it in a separate video. A couple of things to note about the program code that shows the constructor. So you can declare an object of the day of year class by just giving the class name, which is day of year, and then the object names, which in this case they're date 1 and date 2. So what this is doing, it returns an anonymous object, which can then be assigned values. The next one is where they declare date 1 and they give it two values. One is 7 and one is 4. So that automatically makes that object have 7 as the month and 4 as the day. And then the last example is where, remember, we read it from right to left. So we're creating an object of the day of year class, and we're giving it, it's calling the constructor, which gives 5 to the year, to the month, and 6 to the day. Okay, it's create kind of an anonymous object, and then it's assigning it to date 2. A little bit more about the default constructor. It does not have any arguments. It's just open and close parentheses. If you do not include any constructors in your program, the default constructor is created by the compiler, and it's automatically called when you create any object of the class. If you do include a constructor which has arguments, then you also need to include a default constructor where you say what values should be assigned to the private data members. The default constructor sets the private data members of the class. If the class is the bank account class and it has the data members balance, the default constructor would set the balance to 0. And then in the day of year class, month is set to 1 and day is set to 1. I've decided that I'm going to also do a separate video on the creating the class members that can be objects of another class. You can look at it. It's the display 7.3 on pages 298 to 300. So we had talked about using call by reference because it gives the address of an argument. The problem is that that function can then go in and change anything in that argument. So this slide is about how to call by reference to use that without changing the value set to the function. So call by reference is more efficient because it sends the address of the argument. And what you can do to make sure that it's not changed is at the very bottom where it has a solution, you use const as a parameter modifier. So in the example of the printIt function, it's a void function, you put const and then the data type of the variable, and then you use the address of and then the name of the variable. And then it can't change it. So what I mean about all or nothing is that if you use const as one of the arguments and you have more than one argument in your more parameters in your function, you have to use const with all of the arguments. Functions in the class are written with const at the end. So if you had the output, you would put void output, open and close parentheses, and then const with a semicolon in your class definition. Inline functions are kind of unusual. They can be used to reduce the overhead in a program. They're only used for very small functions. The word inline is in the function definition. If you look at the example, if you put inline and then int, it's returning an integer, and the name of it is add, and it has 2 arguments that are both integers. And it's a small function because it's just returning the result of adding A and B. So what happens is that this is put at the very top of, before your main function, and you just have those 2 lines there. And then when your program is compiled, every place that the add function is called, it puts the return A plus B, that whole, those 2 lines in it. I'm also putting display 7.6 in a separate video. This is about static members. If you want to look at the program in advance, it's on page 311 and 312. Vectors are similar to arrays, except they can grow and shrink as the program is running. Similar to arrays in that they store values of the same data type sequentially, and each of the elements of the vector can be accessed using the subscript or the index value. Vectors is a template class. So when you're using vectors, you put vector and then in the arrows your base type. And as in the example, that's creating a vector of integers. So in the example, the default constructor is called to create an empty vector object that will be filled with integers. The vector class has a number of functions that are associated with it. One of the functions is the pushback, and that's used to add elements to the vector. The new elements are added to the end of the vector. Another function will return the size of the vector, which is the number of elements in the vector. This is important because the vectors are constantly expanding and shrinking. There's another function called capacity, and that returns the memory currently given to store the vector. Capacity is usually greater than the current size of the vector. Otherwise, the vector size would be automatically increased. And this can be done manually. So if you have a vector called v, you access the reserve function by using the dot operator and reserve, and then in parentheses put the number of elements that you're going to be adding. In that first example, they're adding 32 elements. In the second example, what they're doing is taking what the size is and increasing it by 10 automatically. So I've copied the program, which is display 7.7 on page 317, showing you an actual program that will create a vector. I have the usual things at the top, pound include IO stream with using namespace std. We also have pound include vector because we're using the vector class. In the main program, we create a vector and we're going to call it v. This is a vector of integers. And then we have instruction for the user, which says enter a list of positive numbers and place a negative number at the end. That negative number will end our loop. So the first, we introduce an integer called next, and then the first number that they wanted to add is assigned to next. So as long as next is greater than 0, it's going to go through these executable statements, which are part of the while loop. It takes whatever that value is in next, and it uses the pushback function to add that at the end of our vector v. And then it's always good to have some output statements so you know what is actually happening. So we're going to output what the value is in next and say added. Then we also are going to output v.size, open and close parentheses, assignment operator, and then we call the size function on our v vector to see what the size is at that point in time. Then we read in the next number that they've entered. It'll continue until next is a negative number. When you finish the loop, it will say you entered, and then it goes through the vector and will output each element in the vector. Remember, our subscripted values always start with 0, so that's why we have int I is assigned to 0 for the beginning of the for loop. And it can't be larger than the size of the vector. So remember, the last element in the array is size minus 1. So that's why as long as I is less than the size of the array, you're fine.